Okay, yeah. So hey guys, my name is Hari. I know some of you that's good. I know some of you that's good. I'm gonna be speaking about Python. Python is a programming language that's used for a lot of things. Not the least of which is scripting, web development, and some other things. Okay, so just quick show of hands. How many of you guys are in 111 or data structures? 111. Okay, I'm freshman. Okay, yeah. Okay, so have you guys coded before have you guys coded before college, before high school and stuff? Like you guys taking like APCS or like something like that? Some of you? Okay. Okay, yeah, that's good for me because that tells me when and where I need to start. So, okay, so with that, I'll get started. One thing I want you guys to do, or like, if you guys have a laptop nearby, just go to this Bitly link. Some of the code samples that I'm going to be demonstrating here, it's going to be accessible from here. You guys can mess around with it, do whatever you want to it, do whatever you want to it through this, and yeah, just paste that right into the text box in your browser, and you should be good. If anyone has any questions, just like raise your hands in the middle. Like I'll just try to get to you whenever I'm done with my sentence. Okay, so of course this begs the question: what is Python, right? Yeah, I'm sorry. Just does everyone get on the link? Okay. No, you're good. Okay, yeah. So it sounds like most of you guys are good. If you're not, or if you're just coming in, like someone who's already logged in can just give it to you. Okay, so with that, we're gonna first start talking about what Python actually is. To say that it's a programming language would be like seriously abbreviating it and leaving out a lot of the cool features in it. As the website says, and yes, there is an official Python website that details a lot of these things. Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Show of hands, who doesn't know what that means? Actually, well, I do. I wouldn't be giving this talk, but that sentence, if I didn't, but that sentence wasn't that informative. So what I'm going to do is I'm going to go through some of the I'm going to go through some of the cool features that Python has that other programming languages don't, which kind of gives you an indication of why and when you would use it. Okay, so to give you guys we're going to have our own separate slide on this, but to kind of spitball and give you guys a little bit of history. First, it was kind of like first when programming became a big thing. When programming became a big thing, and like people started to write code on their own, like companies started to write code. The first big thing used to be C, of course, and then after that there was a trend called object-oriented programming, where like to put it briefly, you can define a class, you can define some behaviors you can define some behaviors that class or that object would have, and you can define some data that's intrinsic to that, and just have that class allocated in memory as just one big contiguous block. Right, so this was a big new thing that C just didn't support. C actually still doesn't support. So the first thing they made on top of that was C++. While C++ was and is still a great language to use for a lot of purposes, some of the things that they lack is that one big problem is that it doesn't run just like universally on all machines. Different computers with different specs and like different server configurations, they have to configure their own things to do with C++, and C, and that was a big problem for some people, because like configuring it would be a bigger job than like writing the code for whatever you're doing itself. So after that, they first made Java as kind of a mature ecosystem. Java is an interpreted language, so all you really have to do is install the interpreter on your computer, and the Java code will kind of just like write magic and kind of run. That actually, it sounds simple in and of itself, but that actually stresses a really important concept that we need to understand before we start thinking more about the things Python can do. Abstraction, right? So the nature of abstraction holds such that there's some really low-level details, some really gory, grimy details about memory. I'm dealing with some of them. I'm taking classes called computer architecture and systems programming. They're all in C. I'm dealing with some of them, but those grimy, gory details that you previously had to worry about in C and C++, you don't need to worry about them anymore because they're abstracted away. There's an interpreter and like there's functionality behind the scenes that kind of does it for you if you just tell it what to do in a high level language like Java or in this case Python. So after Java was made, Python was kind of made as like a scripting language for C aficionados because Python has a lot of similarities with that language. So let's go now to actually get to the slide. Let's go over some of the things that Python actually gives you. First thing is dynamic data types. I'm gonna kind of get over to this point later and kind of just only touch on it now. But quick show of hands, who knows what an array is? Okay, yeah, it sounds like most of you are good with. It sounds like most of you are good with that. But one of the big problems with an array is you only have like a fixed size of memory. You declare it and then like you're done. You can't make it any bigger. There are separate objects now that Java supports and like C++ supports and like C. There is a way to do that, but it's a heavy abstractional problem because if you think about it, you have to. Because if you think about it, you have to reallocate your space and memory to do that. With Python, it's not necessarily like that. The list object, which is isomorphic to the array object that you would have, it's kind of you just keep adding to it and it'll worry about the size. Like you don't think about like where it's going in memory or how much of it it's going in. It's just there for you when you need it and can be arbitrarily big. In theory, like millions of instances big, and like the interpreter won't really give you a problem. So another cool thing that Python has, it's called dictionaries. Most of you in 111, you guys are going to learn about this more in data structures, but there's a very convenient data structure called a hash table, which basically takes some data that you don't know and maps it to some data that you do know. For example, if we were doing phone numbers, then I would just type in Hari, it would just give you like 848482, like et cetera, and et cetera, and like this would be a catalog. This would be like a big phone book catalog that they had online somewhere, right? And that's how you would query it. The important thing about this is you don't have to traverse through a whole list of records to find my phone numbers as opposed to like his or hers. You just give it my name and it'll give it right back to you because it's cataloged like that in memory. So Python actually takes that concept of hashing, and does a lot with it. Case in point, it gives you a data structure called the dictionary that's very flexible, very usable, very versatile that you can use for a lot of things. So that's some stuff about dynamic data types. Generators were not really. They are a thing, but that's not unique to Python. But Python does have great support for it, and it is a very important thing in Python. And that Python, you can't really write Pythonic code without it. So with that said, these two points, you guys are kind of going to see more on this later when we do some examples. But yeah, there's that. And of course, like I wouldn't be able to talk about this point without getting to Python 2 and yeah.
What's a scripting language?
A scripting language as opposed to an interpreted language. A scripting language is you just you basically run it line by line in something called a REPL, right? Something called an interpreter, right? You could think that by that context, Java is a scripting language, but the difference is kind of blurred in that you just write a lot of code in Java and it's expected to just run at a low level. A scripting language is used to model some very high level concept as an abstraction and just give you like a very efficient way to go through that. To give you some other examples of the scripting language, there's one called Bash, which very efficiently like gets to go through your file directories, and then just like go through big streams of text really quickly, and just like give you lines that have a specific feature. There's a scripting language for that. There's a bunch of others, but yeah, Python you could think of it in that context. It's a very high level abstraction that you can use to address some low level features that you otherwise wouldn't be able to as elegantly. So to get to this, the first version that they made of Python is the first big version, I suppose you could say, by the time Python got big. The first big version was Python 2. This went on for a while, but there were a lot of features in Python 2 that made people not want to use it, features in terms of scalability and memory and things like that. So so the developers of Python 2, they took all those concerns and kind of just made a new vision for it. They made Python 3, which is what's industry standard nowadays, and which is what is used in a lot of companies, and that's what you read a lot about in the news and all. This point, I would like to stress, Python 2 is being deprecated in a few months, so any code that you're going to start writing now or that you're going to write anytime in the future, do it in Python 3. So, yeah, the language, to give you guys some more history, was built by a man named Guido van Rossum. He's a very famous Dutch computer scientist. He built it during Christmas. Yeah, he built it during Christmas, specifically as a programming language that's supposed to appeal to like Unix hackers or C hackers, because the two languages have a lot of similarities. Considering that, he actually named it Python because he watched the Monty Python thing and like really liked some of the scenes in there. So yeah, he kind of made a lot of the features in the language to meme what happened in Monty Python. So some trivia for you guys there. We're gonna get to this in a second, but so I'm gonna give you guys like 2 minutes to think about this. For those of you who know about arrays, maybe if you guys could explain it to those of you who don't. What I'm gonna do is I'm gonna take in an unsorted list, right? Or like a theoretically unsorted list, just a list, right? And you're gonna figure out whether it's sorted or not. Okay, so I'm gonna give you guys like 2 minutes to just think about that, maybe come up with an algorithm, and then I'll show you guys how to do it in Python. So just talk amongst each other, think about it. Dan, what are you doing? Mingle. What? Mingle, go talk to other people.
Alright. What's your idea for solving the problem?
What's your idea?
My idea is it's already on the website. It's a array of numbers.
Yes.
Okay, so what you can do is, wait, are you showing this by highest to lowest or lowest to highest?
Lowest to highest.
Lowest to highest. So let's say you find you iterate through the so let's say the order is 1, 2, 3, 5, 4. That'd be
Well, no, I don't think it's
Actually,
there's one that's 3, there's one that's 5, right?
this coffee is delicious.
As soon as you hit 5 and you compare with 4, you see that your highest is lower than the next number. So if that happens, you repeat, you outperform the one you
let's just say we gotta yeah, my dad keeps
because I
You don't have to. You should just need to go to the link.
Oh, okay. It's just like on that.
Yeah, it's just on the link. Yeah, that part. Like, I'll demo that for you guys like in a second.
Oh, okay,
What's up? Okay. Yeah, so it sounds like a lot of you guys. Yo, it sounds like a lot of you guys have some ideas, so I'm just gonna demo the solution real quick. Don't worry, we'll go through more programming challenges soon after this, and you guys will like learn more about the language and cool things that you can do with it. Okay, so first thing I'm gonna do is kind of show you guys some solutions. Wait, why did I do that? This is the first solution. It's wholesome, right? You just loop through the array. You take each index and compare it to the next one. If the first index is greater than the second index for any one, you know it's unsorted. So you just return false. Otherwise, if you go through the whole thing without it working, it returns true. I'll actually show you guys. Yeah,
I didn't get it. You're comparing
I'll explain it in a second.
2 at a time and going through the whole thing.
It's this method, or it's this method up here. Can you guys all see that, or should I zoom in a little bit? Okay. How's that? Okay, so how this solution essentially works is you loop through the array, right? For each index in the array, you take that element and you take the one next to it. You compare those two. If the one at the present is greater than the one next to it, then you return false because then it's unsorted, right? It's supposed to be from least to greatest, by the way.
Okay, so it's gotta be in ascending order, right?
Yeah, it's got to be in ascending order for it to be sorted.
Okay, that makes sense. Okay, I was just I didn't know like what the sorting was.
Okay. Yeah. So essentially, that's how this method works. And another thing I want you guys to mind here is this is how for loops work in Python. If you guys have coded in Java or something similar in the past, you guys will see for int I equals 0, I is less than something else. Yeah, no, that's syntax. Python. The guys who made Python decided it was clunky, so you can do kind of something called a for each loop, which is basically this. In this case, what I'm doing is for index in a range, so it kind of emulates what Java was doing. But you could also do something like this, for I in var, where like var is the list and I would just represent an arbitrary element. In this case, we can't do that because we need the index, but like in general, that's what you would use. You would use a for each loop. But yeah, essentially that's what you're doing. So I also made a test driver for this that we can demo together. So I'll show you guys that right now. Hold on.
Can we ask questions?
Yeah, what's up?
So for that syntax, for this syntax for that for loop, does it only increment that range by 1? What if I want to increment it by 2 if it's high?
What did you say?
For the for loop for this syntax.
Yeah.
So does it only increment it by 1 if it's high?
In this case, yeah, but you could also like just pass additional parameters to the method to make it skip every 2 or every 3. Like, long answer, yes, but you would have to configure a little bit more. Okay, yeah, so now I'm going to test the wholesome sorter, which is what I called it, because not only does it check if something's called, it's wholesome. And I'll explain why it's wholesome as opposed to some other things in a second. Yeah, so it works, right? I actually made a test driver for this where it tests against like some test data. It outputs works if it works and no if it doesn't. Okay, so that's one way to check if it's sorted, but that would be non-Pythonic because Python developers always want their code to be expedient, right? They always want everything to get done in 1 line or 2. They're lazy. They don't want to write that much code. So what they did if you ever want to like make a big loop and you just want to like get that done in 1 sentences, they actually made that go by in 1 line. I'll show you guys how. So this is actually our less wholesome solution, which I will demo presently. Not this one. Okay, yeah. So I want you guys to look at this syntax right here. That keyword all. Basically, you have the loop. You have the loop in kind of a shorthand syntax, and that's the generator that I mentioned earlier, right? Now that I'll get to some more depth into this, suppose you wanted to, and this is actually an example that we'll be doing later. Suppose you wanted to populate a list with all the Fibonacci numbers, right? Or like not even that. Suppose you just wanted the nth Fibonacci number. In order to get there, you would have to store all the ith Fibonacci numbers in the list, right? You'd have to store all of them in the list and get to the nth one. A Fibonacci number is part of a sequence where each element is just made up by adding the previous 2 together, right? So it starts with 1 and 1. So the next one is 2 because 1 plus 1 is 2, and after that it's 3 because 2 plus 1 is 3, and so on.
Thank you.
So if you wanted to do something like that, the thing that I'm trying to stress here is that you would have to store all of them in the list. With Python though, they realized that that was inefficient on memory because you don't care what like the second or third is. You want the nth, and n could be like 100 or like 1,000, right? So they have something called what's inside this method. I'll explain what the all method does later, but they have basically what's inside this method called the generator syntax, right? Essentially what that does is that's an object within Python, and you can kind of use it to just like loop through it in constant memory. It doesn't store any of the past ones in memory. It just gives them to you through a loop. So you could actually just return this from var, and then just like loop through this. If it returns false, then yeah, like you're done. For like one of them, all the all keyword does is it just goes through every element of that generator and checks if all of them evaluate to true. If one of them evaluates to false, the whole thing just returns to false. It does the exact same thing, but the point to see here is that it's more expedient. It's more expedient meaning that it's done in one line. You don't need to worry about it anymore. So there's an even hackier way than that. We have to check if something is sorted, so why not just sort it? You can actually do that with even less code than this in Python, like this. There's a method called sorted, and you just pass a list to it, and it sorts it for you. That's one cool thing, and all you have to do after that point is just check if the original variable is equal to, it has the same contents as your sorted variable, and if it does, then like yeah, you're good to go. If not, it'll just return false. This is even less code and less thinking than the previous example, but it's actually not as efficient. So because like sorting it actually takes more time than looking through each element. Sorting it is actually more inefficient. So
Wait, so the test, that's a list?
yeah, what you're inputting is a list, and you have to check if it's sorted.
Right, so why is it like there's a square bracket, then there's no square bracket?
This.
Yeah.
Oh, that's just the tester class. Like what this is it just takes in a series of tests and just like checks to see if each of these are sorted.
So it's like a list within a list.
Yeah, like this is a list within the list. This is just what I'm using to test. But like this is the actual method where like you're returning false if it's not sorted and true if it is. My bad, I should have specified that earlier, but yeah, like this is another expedient way to do it, but in general you don't want to use this because it's inefficient. That's another thing that you want to balance with Python. There's a lot of really easy ways to do things where you don't have to think that much, but it would behoove you to think a little bit more because then your code is more efficient, it runs faster, and like if you're working for a big company and you're gonna get like lots and lots of data in the future potentially, you want to make it as efficient as possible because like if you're known to be the person whose code breaks, then like it's not a good look. Trust me, I've been in that boat. It's not a
So how do you know it's more efficient? Like it's shorter?
It's actually not shorter, it's longer, but the way you know it's more efficient is, you actually studied this a little bit in the end of 111, but like, if you want to sort a list, like if you want to take an unsorted list and fully sort it, like put everything in order, that has its own complexity. It's defined in terms of time complexities, n log n in this case, but it has that time complexity which is greater than the time complexity of just like going through each element and checking if it's greater than the last one. So, yeah, that's how you know it's more efficient. If it's more efficient, I think Python might actually have a way to check that. Check if it's already sorted before like trying to sort it manually with like whatever algorithm. So, I mean, it might take care of you if you're being stupid like this, but in general, don't. Okay, so with that, we're gonna go back to why use Python. I touched on some of these things earlier, but I'm gonna get to them in greater depth now. Actually with some anecdotes. So one place where you can use, like one big place is backend web development and DevOps things like that. I'll give you guys an example for it actually. One project that I had to do for HackRU, like me and a couple other people, was we basically had to manage everyone's registration systems. Like people had to input their own data, like their own usernames, passwords, GitHub handles, things like that. And we would take them all in, put them in the database. Put them in the database, and if someone potentially wanted to log in, we'd have to provide them something called a login token, which logs them in for a finite period of time and then logs them out, right? Because if they log in on one computer, they shouldn't be logged in there forever. The token should expire after a while. And that'd be the most secure way to do it. So this is a very high level thing. There's lots of requirements to be met. There's lots of things that we need to do right, and we need to do right well. Otherwise, like, the other directors will be like mad at us. So we actually built that in Python. It was a big backend server that worked over a database. It had a lot of requirements. And the reason we built that in Python as opposed to Java or something else was because it supports these high-level abstractions that we can use.
What's an abstraction?
I explained it previously. So an abstraction basically like works out for you some details that you don't have to worry about. Like, you don't have to worry about memory, or you don't have to worry about like whether your programs run. Whether your program's like working good in some cases. It'll just like take care of a lot of things for you. Okay, and because it has these abstractions, right? You can kind of just like build your code, push it out a lot faster. That's one case which Python is very useful and very efficient for. You can also do the same thing in Java, and some traditionalists would argue that you should rather do this in Java than Python. Personally, I don't believe that, because servers have actually been known, especially in the present servers built in Python, have actually been known to perform just the same, if not better, as they do in Java, right? Because Python is backed by lots of C++ abstractions that like make the stuff run a lot faster and a lot more on the lower level, as opposed to Java, which doesn't because it's not used as much, honestly. So, case in point, this is one use case where we would do this. Another one very popular one that's everyone's always discussing in the news, it's data science, right? Data science is a lot of math, a lot of probability theory. So of course there are abstractions necessary. There's going to be big long equations that you have to optimize for, and big algorithms that you'd have to run. So Python is the language of choice for that. However, you can't use just Python, because just Python might not be fast enough. Just Python might not be fast enough because it is a very high-level language, and it's meant for modeling big things, not necessarily running them on a really low level. So while you can use Python for these things as a user, it's usually backed with C++ libraries that have Python bindings, right? And anytime something gets too difficult or too heavy duty, it just passes the data over to C++. Yeah, it just passes the data over to C++, and C++ takes care of it. It can do that, right? It's fast. So one final use case that you can use it for is system-level scripting. Suppose you had a bunch of directories on whatever server. Suppose you had a bunch of directories on your computer, and you literally just had to rename them. You literally just had to change their names for some other purpose, so that like the system admin could get to it. Right? So you could actually do that in a language called Bash, but you can do that in Python as well. You actually are supposed to do that in Python because of its abstraction that abstracts these files, and it kind of just lets you recurse through them and like loop through these big directories and like manage everything very easily without having to think about it too much, actually. So this is another use case where you would use Python. Python is generally actually preferable to shell scripts in situation where like you have to parse a lot of text. Suppose you had to read in the file. Suppose you look through that file and like only return the files that have like some specific attributes, right? Maybe ones that have specific words or specific text features. Maybe only return those and like preclude the rest, right? Python has higher level text abstractions than anything else, so that's where you would generally use that. But there are also other tools available for you in different languages, namely Bash. Right? Bash has some other tools like grep, where it can just stream over a large quantity of lines and just like return the lines that work or something like that, and you could build it just with that. But Python is generally preferable to that because the abstraction is easier to understand and build on.
What's
DevOps?
DevOps?
DevOps is just a name that you're given to things when backend development has to go fast, and it has to go like, it's mostly just a titular thing for the company. company, right? The company is literally just needs to, yeah, like build things out, put them out quickly and plan them, right? That's one field that uses Python because it's, again, planning, deals with a lot of abstractions. It's mostly wrapped up under the category of backend web development or just web development in general. So you would just use Python for the whole category. Anything to do with servers or like web development or Linux, really, like Python is a very useful thing to deal with for it. We already got there. When not to use Python. I'm actually gonna skip over the first one for now and maybe get to that at the end if someone wants to hear about it. But one thing that you need to watch out if you're running Python is that it's stable. One thing that you do have is Python is being updated really quickly. Like right now, the most current version is 3.7. It could be 3.8 later. Later it was 3.6 like a couple months ago. And like if the most up-to-date version keeps changing, it's going to get harder and harder to deploy like something written in maybe 3.4 or 3.2 and on like a new box, right, with the most up-to-date Python version installed. There are ways around this. There are things that you can do called like versioning tools, or like you could just put it in a container runtime, which is basically just the sandbox. You have your interpreter, you have your code, and it basically just runs whatever you give it, and you don't need to worry about it. There are ways around that, but in general, if versioning is an issue and you have to worry about that, you have to worry about it breaking with new versions, you're better off doing it with something like Java that doesn't update as quickly, that's more stable, right? Another thing is when lack of scalability is a problem. I mentioned this previously, but one thing that people generally do to do multiple things at once at the very low level, it's called multi-threading, right? So basically, when you have one memory space and you want to do things at the same time over that, suppose you had a big array and a big array of strings and you just had to look at each string, check for something, right? Relatively easy if it's one operation or two operations, but if there are millions, then you're going to have a problem. So what you do is you do something called multi-threading, which basically looks at multiple ones at the same time. You could look at 10 at the same time or 100 at the same time. And when I say the same time, the CPU clock just executes it in varying sequences, right? It starts one before the other ones are complete. But the thing is, it's executing on the same structure in memory, right? It's executing on the same program space. It's executing on the same structure in memory, right? The problem is C++ and Java allow you to do this, and that's made a lot of applications a lot faster because you can do multiple things at once, in theory. Yeah, in principle, but Python doesn't support that actually. Python gives you an alternative to it. Instead of working on the same memory, you just clone the memory over to a different memory space and you just work on that. It's called a subprocess. You just clone the memory space over to something else and you work on that and work on that within the subprocess instead of working on the exact same thing in the same thread. Python is just designed like that. It's just been like that for a while and people have just been putting up with it because again, no language is perfect, but when that might pose a problem, when you might want to do something with proper thread support, then you might want to look into something else other than Python. The processes themselves are relatively lightweight because the Python memory itself is relatively lightweight, but again, that's not going to go too big too fast for some very highly computational processes. That's one thing to keep in mind. Another thing, there's no efficient serialization protocol. Suppose you had a lot of Python data, suppose you had a big list or a big dictionary and you had to send that over to some other computer, right? Yeah, suppose you had to send that over between 10 servers on your environment, or normally what you would use is a serialization protocol, which would basically just streamline it and make it just very easily computable through lots of different environments. You would just send it over network, right? That's what you would do in Java or C++ or something where the language is easily serializable. In Python, you can't do that because the data structures are, for lack of a better way to put this, so complex that it's just people just haven't found a way to do that. There are tools to do that. There's one thing in specific that comes to mind. It's called cpickle, and that basically just serializes it so that you can ship your data over to different computers. But it's not perfect. It's very far from that. So when this might be a problem, when you might have to send your data over a lot of different computers, you might want to use something else. These are just some use cases where you might want not to use Python. It's great for a lot of things, but it is not perfect. And just to touch base on this again, this is the GIL, the global interpreter lock. That's the thing that doesn't let you multi-thread, right? It makes it so that only one thread can access the memory at one time, right? Case in point, you're only able to run one process on one block of memory before you start on the other one, and that's a problem because that's not how multi-threading works. It shouldn't be. You shouldn't implement something like that. But that's the only way that the data structures are safe and that they won't break internally. So that's why they implemented that. There is actually a project going to remove that and give Python proper thread support, but that's still in working, and it's going to be years, if at all, before that's actually implemented. Do you have a question or no?
Oh, me?
Yeah. No. I thought. Never mind. Okay. So we're gonna do those coding exercises now that I promised. Yeah, the Fibonacci series. I told you guys were gonna see it again. I described what it is here. So I'll just start again. The first two elements are given to be 1 and 1, right? You add those two, get the next one, 3. I'm sorry, you add those two, get the next one, 2, because 1 plus 1 is 2. And then you add 2 plus 1, get 3. Yeah, get 3. Add 3 and 2, get 5, and that's how you compute it. You just add the last 2 numbers to get the next one, right? What I want you guys to do is just write a method to do this. Yeah, just write a method to do this, and it should work. This is actually a 111 problem that has a lot to do with loops. So loops, like you guys might have seen it before. So I'm just gonna give you like 2 or 3 minutes to do that, and as a challenge, like I'll show you guys how to do it optimally, right? I'll show you guys how to. There's actually a way to do this that's more efficient than all the others. It's actually been like a research problem for a little bit. There's a normal way to do it and like an optimal way to do it. I'll show you both. So. I'll give you guys like another 2 minutes. If that works.
guess we can start with 0 then.
Oh, yeah.
Yeah? So it would be 1 to 0.
But
And
this
then,
would be I plus 1 to n minus 1.
why would it be minus 1?
So then, is that because if we're asking for the first number n, so we choose and then add next.
Right. Wait, why?
No, I'm like my mind is blank.
Okay,
Sorry,
okay.
I've been like sitting through meetings all day.
Okay. Does anyone have any ideas? Or,
We're still working through it.
okay. I can give you guys like another minute.
Okay,
Or,
yeah, that's
okay.
fine. So, so this one, right? And then we said it's 1 to 0, right? Then it goes again. Now, this is 1. And then this is 1. So, but then the thing is, okay, let's do this. Let's print this. Let's not print this, like, this is not part of the loop, right? Let's start this as a part of the loop, right? So it does this 1, then it goes back, then 1 plus 1, right? And then it goes back. It's 2 now. So this is 2, and then, yeah, this makes sense. Because I also think this is the thing is, we're gonna add the previous digit, so we're gonna, I think it's gonna be like, I guess it's gonna be 2 loops. This is such a basic question. What you doing?
Okay. Yeah. So, you guys sound like you were working on something. You wanna?
We're working on something, but it didn't make sense, so.
I mean, it doesn't have to be working code. Just what were you guys thinking?
What we were thinking is we're trying to like get a loop so that we can add so that we can get a list. Well, I don't know what we're trying to do.
So, not that we really know Python, but so we would set in it integer num is equal to 0, and then we had a for loop. So while I is equal to 1, and then so we set the integer I is equal to 0, and then while I is less than n minus 1, we add 1 to I at a time. So the loop is basically just the number is equal to I plus the number.
You're right in that you do need a loop, but there's one more thing that you would have to keep track of. You two.
So we were thinking that you have 3 variables, a, b, and c. You set a equal to 1, b equal to 1, and then c equals a plus b, and then you have a for loop.
Okay.
For loop, you make a equal b, b equals c. No, wait.
Initially, you have like a equals 1 and b equals 1.
Okay.
And then you have a loop that does this n times, where you set b equal to a, and then you have like c equal to a plus b.
Yeah.
And then at the end, you return c.
Keep it dancing through the.
It's a solid idea. Yeah, that's a solid idea. That's basically That's basically what I had going here. But I did it a little bit differently. Like it's only just a syntactical thing, but that's basically right. Like that would get you a pass in 111. That would get you an A. So I'm gonna show you show you guys what I had. I called the method suboptimal find just because like there is an optimal one which I will demo to you guys later. So yeah, this is not only a good way to learn Python, but also a fun logic puzzle. First thing you need to keep track of, you have to make your code idiot proof, because oftentimes you'll see this in the industry, the people who are running it are idiots. So you have to make it idiot proof. First thing, if n is less than or equal to 0, you can't have the zeroth number. You can't have the zeroth Fibonacci number, or you can't have like the -5th, right? So just return -1. That's like your common protocol for error, right? If n is less than or equal to 2, just return 1 because you already know that the first and the second are, yeah, you already know that the first and the second are like 1, right? So, and yeah, that's basically where you get to the fun part of this. Like you guys said, you set a and b equal to 1, but you have to, and also like you guys said, you have like a variable that loops through 2 and, yeah, like loops through 3 to n, right? You guys had that part correctly. I think like both of you who are working on it. This is just the syntax to do that in Python. Underscore means you're just never going to address that variable again. You just want to do it that many times, right? In Python, right? And this guy range is actually a generator. The way I was talking about them yesterday, it goes through 3 inclusive to n plus 1 exclusive, right? So 3 to n in this case. N plus 1 is exclusive, so you don't go hit the n plus 1 variable, right? And in each step of the array, you set a temp variable equal to b. You set a temp variable equal to b, and then just increment b by a. And then a becomes temp, or rather what was previously b. Right, so so in each step, you make b the ith Fibonacci number, and you make a the I minus 1th Fibonacci number. This is actually a program called, this is actually like a way of addressing this called dynamic programming. That's actually useful in CS interviews. Like CS interviews, like internship things, like anything that you would see, any real programming challenge that you would see, it's a big thing. The reason it's called dynamic programming is because you take a really big task that's computationally hard and you kind of water it down into otherwise easy problems, right? And you just go through each of them and just solve each one of them. That's basically what you're doing here. You're going to the third one and then the fourth one, and then you're just deriving each from the one before it, and then you're just returning the final one, right? If any of you guys know Big O, like if any of you guys are in data structures already, anyone? Data structures? Okay, yeah, like do you know Big O? Okay, yeah, so this is a good way of addressing it. This is O of n, right? You're going through each element in the array, right? So this is actually like the way that most people would say to use this, but there actually is a slightly better way that's in conjunction with Python, just a one-liner, right? Python is very fond of one-liners. We're lazy, like we don't like to write code, so well, we do because it makes us money, but for not many other reasons than that. Joking, but yeah, so I'll show you guys. So it's actually this solution. Have any of you guys taken linear algebra or just like seen the concept of a matrix before? Just maybe in pre-cal or like, yeah, I think I went to JP, they did that in JP, but like, yeah, like just pre-cal, yeah, just matrices in pre-cal. Basically, if you have the matrix 1, 1, 1, 0, that's going to represent the first Fibonacci number. And a matrix is basically, you'll see this once you get to later on in math, but a matrix is basically a linear function, right? Yeah, you just take something, you multiply it by it, and that represents like linearly adding it or multiplying it a certain times, right? A certain number of times, right? So you take this matrix, you exponentiate it by whatever n is, and then you take a certain index of it. Yeah, you take a certain index of it. Just return that. One that's a one-liner because you're just using a matrix exponentiation library, and like 2 that's even better than O of n. It's for your sake because you're in data structures. It's O of log n. You're gonna see a lot of those. It's log n because in each step you can just exponentiate the matrix again. You can just square it instead of kind of multiplying it out again. You don't need to multiply it n times. You only need to multiply it log n times. Because you can just go to n squared or like n fourth and then n eighth. You can address it like that, and that's faster than going through each n. Like that's faster than going through 1, 2, 3, 4, 5, 6, because you're just squaring it at each step. Right. So yeah. So the way you're gonna do that, this is actually the optimal way to calculate the Fibonacci number. Unfortunately, and I cried about this during 111. You can't. They won't let you do this because they won't let you they won't let you set up a matrix and then just square it until you get to the right number. But yeah, this is a free 111 problem. Enjoy, guys. But yeah, that about wraps this talk up. If you guys have any questions or Python or really about Linux or web dev or any of the things that I mentioned, yeah, just hit me up. I'm on Facebook. I'm always here. Yeah, just talk to me and I'd be happy to tell you guys some more things. Hope you guys liked it. Oh.